Welcome everyone to part 3 of our video on explicit geometric sequence formulas. And we want to carry on from part 2, where part 2 left off was I was completing the table, and I want to just comment on some of the patterns that we're going to need to know as we get ready to do the last step. Pattern number 1 is that in this column, 80, 160, 320, 640, those are the elements or the terms of the sequence. Element, term, same thing. Close enough. The fact is that what goes up here in the exponent is the number of times we've multiplied by 2 to get to that value. So for example, to get to 80, we didn't multiply by 2 at all. Put a 0. To get to 160, we multiplied 80 by a 2 one time. To get to 320, we started at 80 and we doubled and doubled again. So we need a 2 exponent. Multiplied by 2 3 times. Multiplied by 2 4 times. In fact, if you want to know the n number of the sequence, like maybe n is 11, in order to know the n number of the sequence, what needs to go in the exponent of 2 is n minus 1. Only I can type an n on my table. N, there it is. Subtracted by 1, enter, locks it in. And so we can now use this formula or this structure to be able to take whatever position of the sequence that you want, just put in 1 less than that for the exponent of 2. And I'm using Desmos. Shout out Desmos. You should have the app on your phone. It's amazing, or have it ready to be used. But I did 80 times 2 to the 10 power, and I got 81,920. Enter, locks it in. Our formula for an explicit sequence is this one down here. We use 80 because it's the initial term. We use 2 because it's the common ratio. And if n is the position in the sequence we want, n minus 1 will tell us how to get that value. And here it is in practice. We want the 11 number because Mathia said so. Well, we got to put a 10 up here in the exponent. Thanks for watching this video. Feel free to watch all 3 parts. Hope it helps. Let me know. Thank you so much.